So here, did you get the idea? Photon energy falls, a photon falls in a junction and it will create electron-hole pair. Due to this electric field, the electron will move in this direction and hole will move in this direction. We know when charges move, it is current, and this current is known as photocurrent. Okay. When light is focused, to the PN junction, which is in reverse bias, the photodiode absorbs the energy from the photon and produce electron hole pair due to the setup electric field. Due to the setup electric field, the hole and electron moves as shown. Okay. Note this is photocurrent, mention that here it's photon energy. The current due to the motion of charges, the current due to the motion of charges is the photocurrent. Not photocurrent increases when the intensity of light increases. Second, LDR is light dependent resistance, okay? And photodiode are two different components, different components. Okay, done. Our next topic, Zener diodes. Zener diodes. This is the symbol. So on the Zener diodes, write down Zener diodes. Zener diodes are heavily doped, semiconductors which is specially designed specially designed to operate in reverse conditions. Reverse bias condition. When a reverse voltage is applied, a small current is observed until a certain voltage. Afterwards, the current rapidly increases. Afterward, the current rapidly increases rapidly and sharply increases. Rapidly and sharply increases. This voltage is referred to as the Zener voltage or breakdown voltage of the Zener. It is known as This is referred to as the Zener voltage or the breakdown voltage of the Zener. So if we plot the V versus I, if we plot the V versus I for this Zener, V versus I, we use this in reverse, right? Reverse bias condition. Therefore, there is no current and suddenly current increases. This voltage we call as the Zener voltage, VZ. Okay, done up to this. Let's look at an example related to Zener. It is very similar to what we did with diodes. Okay, example one. I'll scroll. Done. So the question is to find the current through the Zener. Okay, we have to find the current through the Zener. Find the current through the Zener. Okay, now here the only difference between the diode and Zener diode is used in forward bias, Zener diode is used in reverse bias. Now here, whatever we did with diode is similar. The first thing you have to do is you have to check whether the voltage across these 2 points is sufficient to break down this Zener. So let's find out V let's find out V without Zener. So V dash is equal to 4 over 6 into 10, which is 2/3 of 10, 6.67 volts. V dash is greater than 5 volt, therefore Zener is active. Now, what is special about Zener? Soon after its breakdown voltage is reached, the voltage will remain the same. Okay, the voltage will remain the same. So here, soon as the Zener voltage is reached, that is 5 volts, now the voltage across this will be 5, across this will be 5. Now we can find what is the current through this I1 and current through this I2. Therefore, we can find the current IZ. So let's find I1 first. I1 is equal 10 over 2, 5 milliamperes. I2 is equal 5 over 4. So that is 1.25 milliamperes. Therefore, IZ is equal 3.75 milliamperes. Idea is clear. Can you raise hand? Oh, sorry. Yeah, 1 minute. Is the calculation correct? Here it should be 5. I have put it as 2. Sorry, I have taken as 10. Across this, voltage is 5. So this is 2.5. This is okay, right? So this will be 1.25. Those who completed this, change this. Put this 2 kilo ohm here, 4 kilo ohm here. Interchange these resistors and try the same question. Interchange the resistors and find IZ. So here the Zener is inactive. Then straight away Iz is equal to 0. Got this answer. Here get this answer. Last example. So you have to find the current through each element. Find Iz, IU1, find Iz and I. First tell me what will be the voltage across these 2 points without the Zener. What will be the voltage without the Zener? So here it's 12 volts. So these 2 points will be 12 volts. So across this, it will be 12, right? Then 50-50. Therefore, 1:1. Then V dash is equal to 6 volts. Okay. V dash is greater than VZ. Therefore, Zener is active. Zener is active. So Zener is active, therefore this voltage will be 5, right? This will be 5. And this has to be, uh, this is 5. Then you should have 12. Therefore, this is 7. This is 12. If this is clear, I1 is 100, I2 is 140, I3 is 120, and I is 260. Copy now. Once I done, let me know. Raja and Shahan. The next part is rectification. Okay, let's discuss rectification in the next class, but I'll send you the note. Just copy it down. When you copy, you will understand what is happening, because you might have studied rectification in modules also, right? So when you read it, you will understand. Anyways, I will explain rectification in the next class. So when you have copied the note, we can quickly cover that section and go to the next section, right? So whatever we discussed today, is it clear? So questions related to diode and Zener diodes. These two are very important. I hope you're okay with this. Try the questions in the past papers, the page book. So I'll end the meeting. Assalamu alaikum.